This video is about samples. We're going to look at three big ideas in statistical sampling. The first big idea is that we examine a part of the whole. A sample is drawn from a population. Population is an entire group of individuals that we have interest in. A sample is a smaller group or subset of that population. Population versus sample. We draw statistics from samples. We draw parameters from populations. A population contributes to the sample. Bias is simply a leaning to one side versus another. When we sample, we may find that we have a certain bias. We choose some individuals more than others. For example, you may like the color blue. You're going to choose a sample from a group of people, and everyone who's wearing a blue jacket or a blue article of clothing is someone that you're drawn to, and you include them in your sample. You have just displayed bias. You're biased to those who are wearing blue. So you have a leaning one way versus another. We all have bias. It's impossible to say that we don't. The goal of sampling is to minimize our personal bias. Soup needs to be stirred. If you don't stir soup, then what happens is you get an uneven distribution of its ingredients. You might get too much salt on the top or the bottom. You might get some of your vegetables in one place and not another. So we always stir up the soup and then we sample it with a spoon, something that's much smaller than the entire population. When we draw individuals from a population, they must be randomized. That ensures that we have less bias. Now, there are many different ways that we can randomize. The simplest way is called a simple random sample. We use dice, or we use a random number table, or we use a computer. We number the individuals, and then we select them based on what our randomizing device told us to select. Now let's watch this short video.
So how can a survey of a small group of people measure public opinion of the entire United States? This idea is called random sampling, where instead of talking to everyone in the population, you talk to a group of people who represent the entire population. Of course, if you want to measure what the entire nation thinks, you can't just stand on a street corner and wave people over. That type of haphazard sample would only represent the people near that street corner at that particular time, and you wouldn't get the people that didn't necessarily want to talk with you. A nationally representative survey requires a random sample in which each person in the United States had a chance of selection. Survey researchers have spent decades perfecting methods to draw a truly random sample that includes all ages, all incomes, all ethnic and racial backgrounds, and all political persuasions. We actually use random sampling all the time in everyday life. For example, when you're making soup, if you stir the pot correctly, you don't have to drink the entire pot of soup to know if it needs more salt. Instead, you can just have a spoonful, because each spoonful tastes like the pot of soup overall. That's random sampling.
So big idea number 3, it's the sample size. Now, we've used this illustration of soup in a pot and how a spoon is the sampler, the pot is the population. But what if you had two different sizes of pots? Does that mean that you would choose two different sizes of spoon? No. The same size spoon will work for both. So this is a fantastic idea, because what it means is whether we're looking at a city, a state, or a country, the sample size can be roughly the same for the same accuracy. So this means that in the world of time and money, we can save both time and money by having the same size sample for different sizes of population. A census is when you look at an entire population. You are attempting to ascertain information about every individual in the population. The United States attempts this once every 10 years. However, there's some reasons why companies, researchers, people in academia would not want to conduct a census. For one thing, it's difficult. It is an expensive proposition. You have to send people, usually researchers. People cost money by sending them places. There's travel expenses. And also, populations are changing while they're being studied. People, for example, are moving in and out of areas as you try to study those areas. And it is more complex than just sampling. Usually we don't take a census. Although, if we had our choice and a census were free, we'd take it. A parameter is a number that describes some characteristic of the population. So you notice how the P goes with the P. Parameters, populations. Statistics, however, describe some characteristic of a sample. You see how the S's go together? Statistic, sample. Statistics go with samples, parameters go with populations.